Homework, a two-paragraph essay on Lavoisier, and we learned that he named oxygen. What else did he name? Hydrogen. And what was the most significant thing that he did? He proposed what? Elijah Close.
He proved wrong the theory of theory of logistic.
What was that again, Elijah?
He proposed the combustion, which is a theory of based on sound mass measurement.
Okay, it's really the law of conservation of mass. And that when you mix things, mass is conserved. It does not disappear into nothing. So he proved the law of conservation of mass. And because of that, he's considered to be a father of chemistry. He just noticed that, recorded it. Now, when you're dealing with the law of conservation of mass, you have to be able to measure things. So we're looking in chapter 2. Last week we looked about introduction to the scientific method. Before we look into measurement, one last little review on the difference between the independent variable and the dependent variable. Remember we talked about that last week, the independent and the dependent variable? So you're watching a commercial on the news, nightly news. They're trying to sell you a medicine. What medicine are they trying to sell you? Anybody just raise your hand? Give me a medicine, just a random medicine. Advil, or I wouldn't try to sell you Advil. Advil's very common. Something new that's on the market. Anybody know of a new medicine on the market? What's that? Antidepressant, a lot of depression going on. So they have a new antidepressant medication, right? So you as the scientist, you have to test this in the lab, and you have to have an independent and a dependent variable. So what is the independent variable? No, it's the medicine. So he just talked about the new medicine. The medicine is the independent variable. So you're going to set up an experiment. You get a group of people, right? What are you going to give the first person? No medicine. A control, like a sugar pill. Is everybody clear? Control is the sugar pill. Then you give the next person what? Right, a full dose. Does that make sense, Daniel?
Yeah.
You're going to give them a full dose. What are you going to give the next person? Under a full dose, maybe half a dose. I want to be writing this down because this is how the science works. Give one person a full dose. We're talking about the independent variable is changing here. Does everybody see that? Independent variable, full dose. Independent variable, half a dose. Independent variable, a quarter of a dose. And the independent variable is what's changing. The antidepressant medication. We have our control is a sugar pill. Patient 1, full dose. Patient 2, half a dose. Patient 3, a quarter of a dose. We'll just stick with 4 patients. Does everybody see that? All right, so what is the dependent variable? No, the dose is the independent variable. The dose is what's changing. The people are the dependent variable. You're going to look for that change. Now, what a lot of people get confused about, they're like, well, that's just one trial. Right? You're doing the sugar pill, full dose, half a dose, quarter of a dose, eighth of a dose, the different doses, right? That's one trial. You have to do this how many times? A lot. A lot of times this is done 100 times, 100 different trials of the same experiment. And then when you get enough data that proves that this does work, then you go to the general population and say, we have enough data that shows this medication is helpful for antidepressant. People who are depressed. Are you following that? So that's how it's done. You do experiments multiple times, over and over again. So you have to think independent variable, choose one, and change its amount. That's how it works. Any question on that? See the marks on the meter stick. Right, see the marks on the meter stick? Just like you see right here. I didn't put them on the board because I'm just not that artistic. Each mark represents a known. So if I have a measurement at 31.1 centimeters, the last blank is your guess. That the blank is associated with the distance between the black marks. So there's a black mark here, and there's a black mark here. That is your guess. Does everybody see what I'm talking about? You must make a guess. How many guesses are you allowed to have? One guess. So if you look at the first paper clip and we put it on our ruler right here, you're allowed one guess. So between the 0 and the 10, you should have one number, only one number. You should have only one number. So this is wrong, this is wrong, this is wrong, this is correct, this is wrong. You could have said 4, you could have said 3. How good of a guesser you are is dependent upon how close you are to what it is. If it's, if it's closer to here and you guess there, if it's closer to here, you guess there. There's a number between, 0 and 10 you're guessing. I'd guess 3. So how good of a guesser you are comes into play in science. All right, so the second one, we put our paper clip on there. Does everybody see how it passes the 4? See how it passes the 4? Anybody not see how it passes the 4? The paper clip passes the 4. So the 4 is what? The 4 is the known. So 4 is correct. It's the known. 1 past the 4 is your guess. So this is your guess. Does everybody see that? Guess, guess. So these are all correct here. Put the circle around that. Everybody, happy face. Yay. Everybody clear? Now the last one, we put the paper clip on, and we see that we have two knowns. We have 4 point, looks like 7. So I'm going to say 4.7. That's the known. 0 is your guess. It's very close to the 7. You have to put the guess there. This is required. You can't just leave it off. If you leave it off, you're saying the ruler is associated with the one above it. These two rulers are not the same. The second ruler might have cost $10. The third ruler here might have cost $100. You can't give the same measurement with a more expensive ruler. So this is 4.75, so that one is correct. Whoever said 4.75, yay, that's correct. This is wrong, this is wrong. So you have to get the one past. You have to guess. Is everybody clear? All right.
The label uses a number in a unit such as 500 milliliters to give the volume. The label also gives the volume as 16.9 grams.
The third most abundant element in your body is
Oxygen.
correction. The most abundant element in your body is oxygen. So the most abundant element in your body is oxygen. Anybody know the percent oxygen in your body? It's around 65%. So 65% of your body is oxygen. And this gentleman up here, Alexandre de Shankatoris, he tried to create a table based on oxygen. Remember, what did Lavoisier do with oxygen? Yeah, he named it. So that's pretty cool. So after you have measured the paper clip, you want to answer a few of the questions?
Oh, okay.
It's like most people have an answer.